Alright, we are supposed to state the domain and range of each relation, then state whether the relation is a function. So for number 1, the domain is each of the x values here. We have x values of 1, 2, negative 3, and 0. You must write it as a set. The range is a set of y values. The y values are 2, negative 4, 2, positive 4, negative 6, and 0. Must write it as a set. The order does not matter. Is this a function? Well, yes, it is. Because when we put these numbers in, put a 1 in, you always get a 2 out. You put a 2 in, always get a 4. You put in a negative 3, you always get a negative 6. You put in a 0, you always get a 0. So definitely a function. Number 2, the domain is negative 2. That's it. Because it's the same thing repeated. What is the range? The range is 9, 8, and 7. Must write it as a set, not a function. It's not a function because if I put a negative 2 in, I get 3 different choices for my answer. I could get a 9, an 8, or a 7. If you get a choice for your answer, then it's not a function. Number 3, the domain is the set of x values once again, 1, 2, 3, and 4. The range is a set of y values, simply 5, 6, 7, and 8. It is a function because every x value you put in, you get to the same y value every time you put in that x value. Number 4, the domain. Remember, when you write things in a set, the order doesn't matter. 8, 7, negative 6. The range is negative 3, 3, and negative 3. Is this a function? Yes. Every time I put in an 8, I get a negative 3 out. Every time I put in a 7, I get a 3 out. Every time I put in a negative 6, I get a negative 3 out. Number 5, given that x is an integer, state the relation representing the function as a set of ordered pairs. My answer has got to be a set. Then state whether it is a function by circling yes or no. My domain for this is going to be 4, 5, 6, and 7, because those are the integers between and including 4 and 7. So if I put 4 in, making sure I substitute with parentheses, 2 times 4 is 8, half of 4 is 2, 8 and 2 is 10. So that gives me 4, 10 as one ordered pair. If I put in 5, 2 times 5 is 10, half of 5 is 2.5, that's 12.5. My second ordered pair. If I put a 6 in, two and a half times 6 is going to be 12 plus 3, it's 15. Finally, if I put 7 in, two times 7 is 14. Half times 7 is 3.5. That would be 17.5. So I have my 4 ordered pairs. I am to write them as a set of ordered pairs. Is it a function? It is. I only get one answer every time I put these numbers in. So it's a function. Number 6, y equals the absolute value of x minus 1.5. My domain is -1 and 0. Not +1 because there's no equal sign here. So I got y equals the absolute value of -1. You substitute, use parentheses, minus 1.5. The absolute value of -1 is +1. 1 minus 1.5 is -0.5. The other integer in my domain is 0. The absolute value of 0 is 0. 0 minus 1.5 is -1.5. Gives me an ordered pair of 0 and -1.5. So my relation has a set of ordered pairs. The set of -1, -0.5, comma, 0, -1.5. Is it a function? Yes. Number 7, you can do this in a couple different ways. What I typically do, in most cases, not all, is get y by itself. To do so, I would square root both sides. That would give me y equals plus or minus the square root of x minus 2. When you do an even root to both sides of an equation, it's plus or minus. So I'm going to have to put 11 into this. (11 minus 2 is 9. Square root of 9 is 3. Now to write this as ordered pairs, I got 2 answers for y. I put one number in and I got 2 answers out. This is not a function for that reason. Sometimes when you put an 11 in, you're going to get -3 for an answer. Sometimes when you put an 11 in, you're going to get +3 for an answer. Not a function. So there's my relation, not a function. On the flip side, you got number 8. Given f of x equals the absolute value of the difference of x squared and 13, find each value. So we substitute, we're going to use parentheses. Simplify order of operations. -4 quantity squared is +16. 16 minus 13 is 3. The absolute value is the last thing we're going to be doing here. So you have to bring those bars down every time. Absolute value of 3 is 3. Number 9, we got f of 2. So we're going to put 2 in for the x values. 2 squared is 4. 4 minus 13 is -9. Absolute value of -9 is +9. Number 10 is a fraction. Some people don't care for that. Deal with it. That's my advice. Three halves squared. To square a fraction, you square the numerator and you square the denominator. 3 squared is 9. 2 squared is 4. I'm going to have to subtract 13 from this, and I'm not going to use a calculator. I'm going to write 13 as a fraction. So it would be 13 over 1. To subtract two fractions, you need common denominators. So to change 13 over 1 so it has the same denominator as a 4, I'm going to multiply the bottom and the top of the fraction by 4. "13 times 2 is 26. 26 times 2 is 52. That gives us 52 over 4. When you subtract two fractions, when you have common denominators, the denominator stays the same. You subtract the numerators. 9 minus 52 is going to be negative. It's going to be negative 43. Absolute value of negative 43 over 4 is 43/4. 4 does not go into 43 evenly, nor do they have any common factors besides 1, so I'm just going to leave it like that. You could change it to a decimal if you want, but if you have to use your calculator to do it, then you shouldn't be doing it, in my humble opinion. Number 11, get the absolute value of the product 5 and m squared minus 13. Squared means times itself. 5m times 5m is going to be 25m squared. 13 is not a like term with 25m squared because this first term has an m in it. It's got m squared in it, and the second term doesn't. Since we can't simplify what's in the absolute value, that means we can't do anything more with this problem. This is as simple as we can get it. (12 through 15), supposed to find f of x equals the greatest integer not greater than x plus 4. Pay attention to the work for this because this will be marked incorrect on a test if you do not show your work correctly. So we have the greatest integer not greater than 2.5. The greatest integer not greater than means to round down to the closest integer if the number you're given is not an integer. 2.5 is not an integer. On a number line, the closest integer on the left is a 2. Once you find that integer, once you round down, you no longer write the brackets. 2 plus 4 is 6. Number 13. Once again, you should not be using a calculator for this. If you are using a calculator, you're probably drinking a tall glass of weak sauce with it. When you substitute, use parentheses. What's the square root of 2? I don't know. You probably don't know either. You don't have to know. What is it approximately? Well, 1 squared is 1. So it's bigger than 1 because this is 2. 2 squared is 4. So it's a less than 2. The square root of this is less than 2. Because if 1 squared is 1 and 2 squared is 4, this number 2 here is between 1 and 4. Therefore, the square root of this is between 1 and 2. So what does 1 point something round down to? It rounds down to 1. 1 plus 4 is 5. So we got f of square root of 2 equals 5. Number 14, we got f of pi. So it's the greatest integer not greater than pi plus 4. What is pi? Don't know what it is exactly, but I know what it is approximately. It's 3 point something, 3.14. I don't know any more than that. I should, but I don't. So 3 point something rounds down to 3. 3 plus 4 is 7. Number 15, f of q plus 1. This is another one you should pay close attention to. So we're going to substitute in parentheses q plus 1. So doing a little bit of thinking here. We don't know what q is. Could be an integer, could be a decimal. We don't know. No matter what that number is, if you round it down, then add 1 to it, you're going to get the same answer as if you added 1 to it first and then rounded it down. So for example, let's say that q was 3.5. If you add 1 to that, you get 4.5. If you then round it down, you're going to get 4. If you take the 1 out and leave the 3.5 in these brackets, and you round it down first, you're still going to get 4. It's not a proof, that's just an example. Hopefully you'll take my word for it. So what that means here, we can take the 1 out of these brackets. If it was a decimal, we couldn't take it out. If it's a whole number, we can take it out. The q cannot come out of the brackets, because if it is a decimal, it has to be rounded down. We don't know what it is. 1 plus 4 is 5. (16) and 17. Name all values of x that are not in the domain. So that's saying find excluded values. Excluded values come in 2 occasions. One occasion is if you have a fraction and a variable on the bottom of that fraction. Another occasion if you have an even root radical. 16, we have a fraction. So to find excluded values, take our denominator, set it equal to 0. Denominator is 5 plus x. Excluded values for this problem, -5. Number 17, similar to number 16 here, we have a fraction. Find excluded values. Take your denominator, set it equal to 0. Denominator is the absolute value of 2x minus 9. When solving an absolute value, you get the absolute value by itself. Once that's done, you make 2 separate equations. If it's an equal sign, which this is an equal sign, then it's an or problem. If it was less than, it would be an and problem. If it's greater than, then it's an or problem. On one of these equations, you simply remove the absolute value bars and solve it. On the other one, remove the absolute value bars and take the sign that did not have an absolute value and make it negative. I mean, technically you can make either side negative, but usually the side without the absolute value is less work. If we solve this one as well, we get this answer could be a 9/2 or a -9/2, or simply put, x can be plus or minus 9/2. Number 18. Same directions, just to find excluded values, what's not in the domain. This has a fraction and an even root radical, so we're going to have to do both things. If I take my denominator, set it equal to 0, this is to find excluded. I get the square root of x squared minus 7 equals 0. To get rid of the square root, I square both sides, add 7 to both sides, square root both sides. When you take an even root, you get plus or minus. So from setting my denominator equal to 0, I got that x is plus or minus the square root of 7. I also need to take my radicand. Radicand is defined as what's inside the radical. Set it less than 0 and solve it. Since this is a less than, I'm going to pretend, since it's a less than and it has an exponent, I'm going to pretend that this is actually an equal sign. And then later we will fix the fact that we're pretending it's an equals. If I solve this, it's going to be the same thing as it was over here. You're going to get x squared equals 7, x equals plus or minus square root of 7. That's not entirely true because we pretended here. So to fix the fact that we pretended, we make a number line. The definition of a number line is a line that has numbers on it. Might want to jot that one down. Since this is less than, we're going to make vertical dashed segments. And we're going to make one of those dashed vertical segments for every solution we got from just this part of the problem, not the other part. We get negative square root of 7 and positive square root of 7. That separates our number line into 3 parts, to the left, to the middle, and to the right. Pick one test point to the left. I'm going to pick negative 100. In the middle, 0, and to the right. That test point gets plugged into the inequality where 0 is by itself. And you don't care what the number answer is, you only care if it's positive or if it's negative. If I put negative 100 in, negative 100 squared is a really big number positive. A big number positive minus 7 is positive. If I put 0 in for x squared, be 0 squared minus 7, which is negative. If I put 100 in, I get a real big number minus 7, which is positive. So what's my answers? Is it the positive ones or the negative ones? Well, it's definitely negative because this says less than 0. So less than is negative. So from this part, it's saying that x is between, but not including, square root of 7 and negative square root of 7. If you combine this answer, which says it's between those numbers, and this first answer, which says it includes those numbers, we get our excluded values are between and including negative 7 and 7. Number 19, use a graphing calculator to determine whether each equation is a function. If you put this in your calculator, it's going to look something like this, where the x-intercept is 5. Notice, when I drew this, from looking at my calculator or from other reasons, I know where this graph is. I don't have to count 5 spaces to the right and draw it. By me putting a 5 here, I'm saying that every space on this x-axis is 5. 5, 10, 15, 20, etc. If I don't label the y-axis, I'm not saying what those values are. And I didn't label it, so I'm not saying. But it goes to the right much faster than it goes up. Is this a function? Well, using the vertical line test. If I take an imaginary vertical line, or in this case, this red one that you can see, does it hit the graph more than once at the same time? It does not. Therefore, it is a function. Number 20 is not as simple. The reason it's not as simple is because y is not by itself. I am going to use a calculator for this. The directions say to, but besides that, I'm going to be multiplying some big numbers here, big for me. If If you can do it in your head, that's better than what I'm doing. I want to get rid of my fractions. I'm going to multiply each term by 9. By doing that, I get rid of those 9's, which means this is no longer a fraction. I still have this 16 here, so I'm going to multiply each term and then by 16 as well. This property that I'm using is called the multiplication property of equality. It says that you're allowed to multiply both sides of an equation by the same number, and it doesn't change the equation. It might change how it looks, but it doesn't change its values. So I'm multiplying by 16 and dividing by 16, so they cancel. So what that gives me is 16x squared plus 9y squared equals 144. In my opinion, this looks a lot better than the original problem. Please note, if the original problem had any variables in the denominator, we would have to find excluded values. It doesn't, so we don't have to do that. Trying to get y by itself, I'm going to subtract 16x squared from both sides. Then divide both sides by 9. 144 divided by 9 is 16. I know that because I multiplied 9 by 16 to get 144. Leave this as a fraction, 16 over 9. Get y by itself, you square root both sides, and you get plus or minus the square root of 16 minus 16/9 x squared. When you put this in your calculator, you have to put it in twice. Into y1, put the positive version of this. Into y2, put the negative version. Doesn't matter which one goes where, but it matters that you put both of them in to get the complete graph. Let me do that real quick. Ends up being an oval. If you hit the trace button, there's other ways as well, but if you hit the trace button, it'll give you what these intercepts are. Here we're going to get 4 and a negative 4. Excuse me. And then here we're going to get 3 and negative 3. Is this a function? No, because if I run a vertical line over this, I can hit the graph in more than one place at a time. (21) A recycling center accepts aluminum cans for recycling. A weekly record from the center is shown at the right. So we got Monday, Tuesday, Wednesday, Thursday, Friday. Number of cans recycled in the second column. The pounds of aluminum that you get from those cans in the third column. Can you use the information in the second and third columns of the chart to illustrate a function? So a function is you put one number in, you always get the same result. Well, I can do that if I take this column and make that the x values, and this column and make it the y values. So the question was, can you use the information in the second and third columns to illustrate a function? Yes. By making the pounds of aluminum produced the x values, and number of cans the y values, this illustrates a function. It says to explain. I'm not going to write this out. You should. The explanation is, if I pick a number from these x values, from the pounds of aluminum produced, I get the same answer every time. If I put in 3,000, I get 75,000. If I put in 2,850, I get 70,000. Second part of the question, can you use this information to illustrate a relation that's not a function? Certainly. If I make the x values number of cans recycled, and the y value the pounds of aluminum produced, it's not a function. Here's the reason. You would be writing this. I'm just going to explain it. It's not a function because if I put in 75,000 cans, I can get two answers. Sometimes I'm going to get the answer of 3,000. Sometimes I get the answer of 3,100. The formula of the simple interest earned on an investment is I equals PRT. I is the interest earned, P is the principal, and R is the interest rate. If your variables are defined as well as these are, explicitly highlight them, underline them to some degree. If they're not specific, you need to write down what each variable stands for. Assume that $5,000 is invested. Principal is how much money you're investing. So 5,000 is the principal. Interest rate is 8%. That is interest rate R. And that the interest is added to the principal at the end of each year. Find the amount of interest that will be earned each year for 3 years. So we take this formula, I equals PRT. I is the interest earned. We don't know what that is for this problem. The principal is $5,000. Interest rate is 8%. As a decimal, it's 0.08. Time. Seems like a trick question, but it's not. How much time is there in the first year? 1 year. Using a calculator, I multiply 5,000 times 0.08 times 1. I get $400. So the bank says, after 1 year, we're going to give you $400 back because you let us use $5,000 of yours. Then we go to year 2. It says that the interest is added to the principal at the end of the year. So when I go to year 2, my principal is not $5,000. It's $5,400 because I add the $4,000 from year 1 to the $5,000 original. Once again, this is not a trick question. During the second year, how many years was the money in the account? It was in there for 1 year. 5,400 times 8%, $432. Year 3, interest equals principal times rate times time. You do need to write the formula every time you use it. Principal, I take 5,400 and add 432. That's $5,832. Technically, I should have been using parentheses when I substitute these things in. 1,000 pardons. Interest rate is still 8%. The third year is only 1 year long. 5,832 times 8%, $466.56. You got to be careful here when it says state the domain and range. Sometimes common sense supersedes the math principle that I taught you. State the domain. Well, technically we put ones in each time. So the domain would be 1, 1, 1, but that's really not what's happening. The domain for this we're going to define as the year. So our domain is year 1, year 2, and year 3. The range we're going to define, I can do it in one of two ways. I'm going to see what the answer key says, so I do it that way. Yeah, the range we're going to say is the interest earned. Another way to do it would be to say the total money in the account could have been the range as well. If you did yours that way, it's not wrong because the directions aren't clear. So the range is $400, $432, $466.56. Is this a function? Yes. Why? It's a function because when you put a number into the domain, you get the same answer every time for the range. Every time during year 1, I'm going to get $400. Every time during year 2, I'm going to get $432. Every time during year 3, I'm going to get $466.56. It fits the definition of a function.